And the topic for today's discussion is National Green Hydrogen Mission. Before that, we have to know what is exactly green hydrogen. So first, you can see here brown hydrogen, gray hydrogen, blue hydrogen, then we have green hydrogen. So higher carbon includes brown hydrogen and green hydrogen. Brown hydrogen means what? Hydrogen produced as a product of industrial process. So that hydrogen which is produced as a product of industrial process is known as brown hydrogen. Then we have gray hydrogen, where hydrogen produced using fossil fuels. Then we have blue hydrogen, where lower carbon involved in comparison to this brown and gray hydrogen. So here hydrogen produced using fossil fuel, but carbon dioxide is captured. You can see here in this picture, the carbon dioxide is captured here. Then green hydrogen. Hydrogen produced using electrolysis powered by renewable electricity or nuclear. No carbon, that is zero carbon involved here. So gray hydrogen, natural gas is passed, then carbon dioxide is produced, and this hydrogen also. This hydrogen is known as gray hydrogen, as we are using natural gas and we are not capturing this carbon dioxide. Then blue hydrogen, the carbon dioxide produced is captured underground the source. So natural gas as an input, hydrogen is produced, and this carbon dioxide produced is now captured in the underground. Then green hydrogen, electrolysis process. So green electricity plus water. Hydrogen is produced, only oxygen is produced as a byproduct. That is good, right? No carbon is involved here. I hope the picture is clear to you now. Now, Union Cabinet has cleared 17,419 crore national green hydrogen mission that aims to facilitate the production of hydrogen from renewable energy. So the amount that is being allocated to National Green Hydrogen Mission is 17,490 crore. We know this hydrogen is an essential industrial fuel that has a range of uses, from producing ammonia, making steel, cement, and to powering fuel cells that can run buses and cars. So this hydrogen is kind of versatile in terms of uses, because it can be used in many different purposes. The cheapest way to manufacture this is to rely on fossil fuels such as coal, natural gas, and that produces carbon and emissions. The concern here about the global warming and the gradual but steady embrace of alternative fuels have stoked the world's interest in producing hydrogen from renewable energy sources like, solar and wind energy. Yes, we can produce the hydrogen from means coal, natural gas, and that will be the cheapest way. But the bad thing here is the associated carbon emissions. So now, what the global concern is on with respect to this global warming is pushing them to produce hydrogen from renewable energy sources. Instead of this coal, natural gas, we need to move to solar and wind energy. Now, we have to look why we need hydrogen. I already told you that hydrogen is used in means in many cases. So that's why I have used the term versatile for hydrogen. You can see here power generation, synthetic fuels, hydrogen vehicles, ammonia fertilizers, metal refining, heating. For all purposes, we are using hydrogen. This National Green Hydrogen Mission aims to create an enabling environment for the Indian industry to develop the infrastructure to produce and transport green hydrogen from certain nerve centers to production hubs where they can be used in various industrial applications. Now, till now, this NS or you can say National Greenhouse Mission has committed to finance, but the details are not available yet. The manufacturing of electrolyzers, which use electricity to split water into hydrogen and oxygen. Remember, yeah, water should be used because water, that is H2O. So we need to split water into hydrogen and oxygen. And for that, what we need is electrolyzers for the electrolysis process. And because of the entailed expenses, green hydrogen currently accounts for less than 1% of global hydrogen production because it involves a cost, right? So that's why only less than 1% global hydrogen production is going on. And India aims to become a global industrial hub and exporter of such hydrogen. Union cabinet, if we see in summary, we can relate this with this like expected deliverables by 2030. Up to 2030, what is our aim? At least 5 MMT green hydrogen annual production, 60 to 1000 gigawatt electrolyzers capacity, 125 renewable capacity for green hydrogen generations and associated transmission network. So overall total cost is 19,744 crore. And as a result, rupees 1 lakh crore import savings will be there. 50 mmT carbon dioxide annual emissions averted. That is the most important case because current days, because of this carbon dioxide emissions, global warming is going there. And because of that global warming, climate changing is taking place. And for that, we can see that what are the devastating effects. Right now, you know about that in Himachal Pradesh and in those northwestern India, such type of flooding is occurring where we rarely see before, right? So all this because of the climate change. Then also this will create around 6 lakh jobs and 8 lakh crore investment is there. This chart is very important. So just remember, because of this green hydrogen mission, where we are approving 19,744 crore, will get as a result like 1 lakh crore import savings, because for that fossil fuels, we have to depend on import energy, right? Now that will be safe, 1 lakh crore import savings. Then 50 MMT carbon dioxide annual emissions abated, and 6 lakh jobs will be created, and 8 lakh crore investment will be done. The first such green hydrogen power plant is at Jorhat, is established at Jorhat with incorporation, means with the help of All India. You can see here, this is the India's first green hydrogen pilot plant that has been commissioned in Jorhat, Assam. So this looks like this. So we hope that many such plans will be established, and that will fulfill our need towards the 2030 aims of adopting green hydrogens and averting the carbon dioxide emissions. So with this, I'm ending this session. Thank you very much.